Hey there students, Mr. Fugate here. In our video today, we're going to be going through an overview of what we'll be doing in our next lab, Lab 2G. Now the title of this lab is actually Catch Me If You Can. The numbering may change a little bit depending on the year in which you're watching the video. Sometimes we do the labs in a bit of a different order, but the title of the lab should be Catch Me If You Can. Now, what we're going to be doing here, and this is in Unit 2, so we're going to be looking at the idea of kinematics and motion. Specifically, we're going to be using what we've learned about graphical kinematics to analyze the motion of a few moving objects. So, here's what we're going to have for our lab for today. We're going to have two of the constant velocity cars. Hopefully these look a little bit familiar. We've worked with them prior to this. These are relatively straightforward. They have an on-off switch, so I can turn the car on and get it moving across the table. And so we're going to have one car that should be at what we call a stock speed, just a normal speed. And then we'll have a second car that's going to be at a reduced speed. And if I turn this car on, you'll notice the wheels turn a bit slower. This one also goes backwards, so I'll turn it around. So it moves at a slower speed. So here's going to be our objective for what we're doing. We're going to take our two cars, and individually, we're going to start by collecting some data on each car so that we can make a graph of position versus time. So what we'll start with in our lab is that we want to generate a graph of the position of each car as a function of time. Effectively, we're going to model the car's motion as a graph of position versus time. So what you'll need to do for each car to start is actually get the cars moving and then collect some data on how far the cars travel in a set amount of time. Now, eventually, once we have our graph of car 1, we'll actually also generate a graph of position versus time for car 2. And one thing we'll want to look for is the slope of our line for each car. As we mentioned, one car should be moving at a slower speed, one should be moving at a higher speed. And as we've talked about with graphical kinematics, for a graph of position versus time, remember that our slope should give us a value on our velocity. So this will be one way that we can actually see how the velocity of the cars, their speed effectively, is different. So this is going to be our first part of the lab, just setting up a way to model the motion of each car. Now, once we have a graph of each car's motion, what we'll also want to do is then we're going to put actually each data set on one graph. So imagine we'll have one graph for car 1, we'll have another graph for car 2, and then we're going to make a graph that has both car 1 and car 2 on it at the same time. So we'll have a third graph where we've got position versus time, but we'll have one car and the second car on the graph at the same time. And this will be a way that we can visually see that we have different slopes, meaning we have different velocities for each car. Now, in order for us to accomplish this third graph, we're going to need to make sure we control time when we are collecting data. What specifically do we mean by controlling time? That means you will need to get a position value, how far the car travels, at set time values. In order for us to have two different data sets on the same graph, the way the spreadsheet is going to work is that we need to have the same values on the x-axis. So what we'll want to do here, sorry about that, tend to be clumsy sometimes, is we'll want to make sure we get a position at set times, 1 second, 2 seconds, 3 seconds, that sort of thing. Now it may be challenging to do that, especially with the fast car every second. So what we may do, and again, I'll leave this up to your group, is that we may in fact collect the position every 2 seconds. Now we'll need enough points to be able to generate a relatively clear trend. So we'll want to have at least 5 position points for each car. So you'll want to make sure we can have 5 times. So 2 seconds, 4 seconds, 6 seconds, 8 seconds, 10 seconds, that sort of thing. And again, we'll leave it up to you on exactly how many points you collect, but we'll want at least 5 points so we can get a pretty good idea on the car's motion. Okay? So hopefully that gives us an idea on where we'll be starting our lab. We're just going to begin by generating a model of the motion. Once we have those, here's what we're going to do next for the more challenging part of our lab. We're going to take our stock car, the one that's moving at our normal speed, the one that goes forward. We're going to start that at a position 0. Imagine we start that at the end of the meter stick, if you will. Now the slow car, because it's moving slower, if we start them at the same point, the fast car is always going to win. So we're going to give you all the challenge of, we're going to start the slow car a certain distance away from the fast car. And we're going to ask you to use your position versus time graphs to try and predict where the cars will meet. Here's what we mean by that. I'm starting my first car here. I'm going to start them at the same time. And again, I'll probably run out of space before I do this on the table. I'll maybe start them closer. We want to try and find the point in which the cars will cross. And so hopefully that gives you an idea on what we're going to do. Now, we're going to space the cars out a little bit further so the meeting point doesn't happen immediately. But that's what we're looking to do. We're trying to find the point in time where the cars will meet. Now, in order to do that, we're actually going to have to take our graph of position versus time and make some adjustments to it. So we'll talk a little bit about that here conceptually, and then here in a moment I'm going to transition over where you'll see a screen, and I'm going to walk through how I would do this with my data points. So I've got a graph of position versus time. This is where we're going to end after part 1. We are eventually going to generate a graph of position versus time that has both of our cars' data on it. So imagine we've got car 1, we'll say that's our fast car, and then we've got car 2, which is our slow car. Now again, as you can imagine, if we start the cars at the same point, then car 1 is always going to win the race. It will always be moving at a faster speed, so they will never cross. What we actually want to do is change the starting position of car 2, meaning at time 0, we want to move car 2 up so that it begins at some position ahead of car 1. Maybe we want to start this at something like 30 centimeters or 0.3 meters away, something along those lines, okay? Again, we will come by and give you a set starting position, but I am just going to pick one here for the sake of our example. And what we will want to do is we'll want to adjust our graph, and we're going to talk about how we'll do this. We want to take the existing graph we have and actually shift one of our lines up to try and see where our cars are going to meet. We'll try and find the point and time where that intersection will happen. That is our overall end goal with what we're trying to do. To get there, as I mentioned, we'll need to start by modeling, or the other way, we'll need to start by modeling the motion of the cars separately. That's going to be kind of day 1 of what we'll do. And then eventually we'll get to one graph that has both of our cars' data on it. And then we're going to change the starting point of our second car such that we have a gap for the first car to try and catch up. And we'll try and make a prediction on where that meeting point is going to happen. So hopefully that gets us moving in the right direction here with what we're going to do with our lab. Here in a moment, we're going to transition over and I'm going to walk through how we'll take our existing data and make a bit of a transformation so that we can adjust our graph to be able to make our prediction. And so we'll transition over there now and finish things out with our example.
Okay, so now that we've taken some time to walk through what our procedure is going to look like, we're going to take a few minutes and look at the analysis side of our lab. I do apologize, I've been a bit congested today, so I'm sorry if that's coming through in the audio, but I'll do my best. So what I've got here is the data that I've generated for both of my cars. Now, I've labeled here car 1 as my stock car, that's the regular speed car, and then car 2 is my slow car. Now, as we discussed, we're looking to make a few different graphs here. One is going to be a position versus time graph for each car. So the first thing I'll do is for each car, I'll go ahead and click on the time and position. I'll select all of those values for one car and generate a graph. Now there are a couple of ways I can do this. There is an insert chart button over here. You're welcome to use that, or you can go to insert and then chart. Okay, so go ahead and hit insert chart and I'll see what the spreadsheet gives me. Okay, so here, just by kind of experience, I know that this is actually not the chart type that I want. What we are looking for is we're looking for a scatter chart. So I'm going to go over here on my chart editor. If that doesn't automatically pop up, simply go to the three dots in the top corner, hit edit chart. I'll go to my chart type, and then I'm going to scroll down until I see scatter. I'll click on that. There we go. Okay, now I don't necessarily want car 1 stock. Okay, I'm going to go ahead and change my titles here. On the horizontal axis, I just want time. So I'll delete that off. And then on my vertical axis, I just want position. And then for my overall title, I'm going to change this to position versus time. And I'll put car 1 after that. I personally like to center my title and then possibly bold it just so I can see the title a bit more clearly. Okay, so it looks like here I've got a relatively constant slope, which for my position versus time graph is going to tell me I have a constant velocity for my object, which is hopefully something we should expect given that our carts have a pretty constant speed as they're moving across the ground. Okay, now what I will also want to do is I'm going to go ahead and hit edit. I'm going to go over and customize. I'll go to series, and then I'm going to scroll down to trend line, and then I will go ahead and go to the label feature and hit use equation. Okay, now as we've talked about for a position versus time graph, it will tell us directly where the object is located at different points in time, but it will also tell us something more about the velocity of the car. Specifically, our velocity should be the slope of our position versus time graph. And here, since we have a nice constant slope, that means we should have a constant velocity. This equation up here, this 0.255x, excuse me, plus 0.0257, that is actually the equation of our trend line in slope-intercept form, y equals mx plus b, where m is our slope value. So this value here, this 0.255, that is actually the slope of our car in units of meters per second. So for my stock car, the value is 0.255 meters per second for my velocity. Now, I actually just kind of generated this data just based off of some old data I'd collected. I would not suggest necessarily using this data for your analysis. This is just kind of data I randomly generated from my own work. Okay, so now I've got my graph for the first car, and I'm going to do the same thing for car 2. So I'm going to select time and position. I'll go ahead and go to insert and chart. Okay, now again, it has some titles on here I want to adjust. I'm going to go ahead and on the x-axis, delete off everything except for time. On the y-axis, I'll delete off everything except for position. And then on my overall title, I'll change this to position versus time and car 2. Again, I like to center the title. There we go. Now as well, on my customize options, I'll go to series and trend line. And then I'll go ahead and scroll down to where I see label, and I'll hit use equation. Okay, so now I have my two graphs, one for car 1 and one for car 2. I'm just going to drag these over here. Okay, so now I've got both of my graphs, one for car 1 and one for car 2. Now, as we also talked about, our graphs should both show position versus time. For car 2, that was my slow car. Notice here that my slope is a bit lower, or 0.143, rather than my stock car, 0.255. Okay, so now that we have both of our graphs of position versus time, we actually want to generate one graph that has both cars' data on it. So here's what I'll do. I'm just going to go ahead and go to I'm going to go to my chart editor, just say for car 1, and I'm going to hit copy chart. Now what that should do, I want to duplicate. Let's see if it gives me that option. It may not necessarily give me a duplicate option, so I'm just going to leave that as it is. Here's what I'm going to do. I'm going to select position and time for one car. I'm going to go ahead and hit and chart. So I'm going to make another chart. And on the x-axis, I also want time. On the y-axis, I'm going to have position. But now I want both cars, both a car 1 and car 2. So for my overall title, I'll go with position versus time. And I'm not going to label this car 1 or 2, since I will have both cars on here. So right now I have the data from car 1, but again, like I saw in my first chart, it doesn't give me the chart type I want. So I'm going to go to my editor, go down to scatter. This looks good. Okay. Now what I also want to do is I want to put my other car's data on here. I'm going to move my current graphs over just a little bit so you all can see things a bit better. Okay, and I'm going to put this just kind of over my first car. Okay, now here's what I'm going to do. I'm going to go to my editing options, and then on my on my series, I'm going to add another series. Now, this is why it was very important that we control time. Our x-axis values should still be the same, time 1 second through 7, but I'm going to add other positions at those same times. Okay, and that is why it was important that we control time so that we have the same times but different positions for our other car. So I'm going to go to Add Series. I'm going to go to this Select Data Range option, and now I'm going to select my positions for car 2. I'll select down and hit Enter. And now I've got my positions for car 2. Now, one thing I'll want to do is I'll probably want to go and adjust my titles here. So for the blue, I'll label that car, or sorry, for the red, I'll label that car 2. And then for the blue, I can just, again, click on that. It's an editable text box, and I'll hit car 1. So now I'll get both of my data points on my graph. Now what I would like is I would like to make sure I've got a trend line. And when I click trend line, that should now generate a trend line for each of my cars. Right now, I'm not as concerned. I can go ahead and put my label and use equation on there, so I get my equation for both. I'm mostly concerned with this final graph, that I can see both of my cars' data on one singular graph. Okay, now you will notice at this point, the cars do appear to have a point where they are going to cross. Now, that may seem a little bit problematic because of what we're going to look at here in just a moment, but ideally, both of our cars should be beginning at point 0, 0, meaning at time 0, they're at a position of 0. Now, that may not necessarily be the case, given that for our cars, we've got a bit of a y-intercept. So I'll notice, especially for my second car, I do have a y-intercept there. Now, I'm wanting to make sure. It looks like I'm going to just kind of double check some things real quick over here. Okay, sorry for the delay there. I noticed that there was a bit of an issue with how my graph was actually grabbing my data points. So I did go ahead and make a slight adjustment. Ideally, I shouldn't see that my lines are crossing yet. What I should see is I see car 1 here. That is going to be my stock car. It has a higher velocity, a higher slope, so it should have a steeper incline on the graph. And then my slow car down here has a lower slope. I shouldn't necessarily see those values crossing. Okay, now one thing I want to make sure I check is my y-intercept. Ideally, this value after 0.255x, this value here should be relatively close to 0. Ideally, our car started at 0, 0. If you are noticing that your data points don't necessarily, or they do have a pretty high y-intercept, what you may want to consider doing is going through and inserting a data point of time 0, position 0. This is going to force our cars to go through the origin, force our data sets to go through the origin, which may help clean up our y-intercept just a little bit. Technically, our cars are at position 0, at time 0, and if you're noticing that you have a pretty big y-intercept, then you want to go ahead and add that point in because it will help adjust our data points a bit. Okay, so now we've got all three of our graphs. We've got position versus time. Again, it's a little bit hard for me to space these. I may make them a little bit smaller. I've got position versus time for car 1. Then I've got position versus time for car 2. And then down here, go ahead and drag this over. I've got position versus time for both cars. So this would be a complete set of data for all of part 1. We've modeled the motion of both car 1, car 2. I may want to go through here on car 2 and do a little bit of work editing some things here just so it matches up with my second graph. If I want to go and adjust my color to red, that way things on a car 2, they match. That way it's a little bit easier to see what's going on there. I can do that. But now I've got all of my data for the first part of what we're going to do. So we're going to take a moment now and we'll transition over and we'll look at how we can then use our models to make some adjustments and make a prediction on where the cars meet. Okay, so now that we've made all of our graphs for car 1, car 2, and then both cars together, we're going to look at how we can make an adjusted model so that we can make a prediction on where the cars will meet. So what we'll do here is I'm going to go ahead and make a new sheet. So I'll hit duplicate. That's going to take the current sheet I have and duplicate it over. Okay, so it might be helpful if I give a sheet 1 a title. So maybe I'll do something like raw data, something like this. And then on my second sheet, I'll look at predictions and call this maybe adjusted data, something like that. Now, I don't necessarily want you to get the wrong idea. We're not going to be changing our data points directly, but we will be making some adjustments so that we can look at the point at which the cars will meet. But I want to make sure we have our raw data here so we have a place where our initial data is not going to be changed. So I'll go to my predictions tab, and here's what I'll do. I'm going to go ahead and delete off these two charts because now I'm not as interested in what the cars are doing separately. Okay, so here's what we're going to do. What we want to do is make a prediction on where our cars are going to meet. Now you'll notice that's going to be a problem if our cars begin at the same point. So what we will want to do is we actually want to take this graph, or the data for car 2, and we want to slide that line up, as we talked about in our video previously. Now, how am I going to do that? Well, right now, my y-intercept, where my red line, crosses the y-axis, the position axis, is 0, meaning at time 0, my car starts at position 0. If we start things this way, as we mentioned, car 1 is always going to outrun car 2 because it has a higher velocity. So here's what I'm going to do. I'm going to adjust and set aside over here what I call a new starting position in meters. Okay, and I'm going to go ahead and tab that over. And here's what I'm going to do. Let's say that I want to adjust car 2 to be at a starting position of, let's say, 25 centimeters. I'm going to type in here 0.25. Now, the reason I'm going to do that is so I can actually go back and adjust that starting position to be whatever I want. That way, I can actually change my starting position right here, and it's going to automatically adjust my positions. So here's what I will do. I'm going to take my original data, and I'm going to take that number, and I'm going to type in a formula. So I'm going to put equals, I'm going to go adjusted position, and I'm going to put equals my original position plus my new starting position. So what I'm going to do is I'm going to take my original position and add in this new starting position. What that's going to do is that it's going to take all of my data points and shift them by this value, 0.25 meters. So I'm going to hit select. Now it's going to ask me if I want to autofill that. Now what I'm going to do here is I want to show that formula real quick. It's going to take D4 plus F2. Now if I do that, if I drag this down, here's the only problem. And now it's saying D4 plus F3 plus F4 plus F5. I don't actually want to copy this cell down because I want to keep that cell the same. So what I'm going to do in my equation is I'm going to lock that cell by using a $sign. So now it's going to lock that cell in place so that when I copy my formula, it's only going to copy this cell over here. It's going to take D4 and it will adjust that down, but it will leave F2 set. So now when I click and drag, I now see that all of my positions have been adjusted up by 0.25 meters. Now you could go through and do that by hand, but now the nice thing is I can actually give you any starting position and I can type that in and it will recalculate a new position data based on our original data. I'll go back to what I had a moment ago. But again, the key there is I want to use that $sign so it will lock this cell, my new starting position, and then it will recalculate my points off of that. Okay, so now I'm going to come back to my graph. I'm going to hit Edit Chart. And on my series, I actually don't want column D anymore. Now I want column E because I want to graph my adjusted position. So I'm going to remove this. Then I'm going to hit Add Series. And I'm going to go to column E. I think it had 2 through 11 is what it was graphing. Oh, sorry, I missed my. So I'll go to Edit. I'll hit Add Series. I'm going to go to Select a Data Range. And I'm going to go 2 through 11. I'll hit Enter. Okay, it is using a row 2 as headers. Great. And now I'll go ahead and close this. And I should now see approximately the point where the cars are going to meet. That should be for my adjustments at a time of around 2 seconds. And we'll be at a position of, it looks like, between 0.5 and 1 meter. So maybe about 0.55 or 0.6 meters, something around that time. And again, the great thing is I can actually change that starting position to be anything. It will recalculate not only my data points, but it will also replot my line. So now I can look at adjusting my starting position however I want, and it will recalculate my data and recalculate my new adjusted position line so that I can see where my cars are going to meet. And again, all of this is done without having to adjust our raw data over here. We're just making our adjustments to our data here in the second sheet. So hopefully this gives us a pretty good idea on how to make our adjustments. As always, if you have any questions on what you're working on, please feel free to let your instructor know, and we'd be more than happy to take the time to go over things with you. Other than that, good luck.